In this video, we're going to look at neutralization reactions. The first one we'll look at is what is a base. We'll then look at what neutralization reactions are, and then we'll look at what salts are and how we name salts. Bases are substances that can neutralize acids. All acids contain hydrogen ions, and that's what makes them acidic. So when a base reacts with an acid, it removes the hydrogen ions from the solution, and that means that the pH of the solution moves closer to 7, which is neutral, and that's why it's called a neutralization reaction. Bases include compounds of either metal oxides, such as calcium oxide or sodium oxide, metal hydroxides, such as calcium hydroxide and sodium hydroxide, or metal carbonates, such as calcium carbonate and sodium carbonate. Although we call these metal oxides, metal hydroxides, and metal carbonates, they're all called bases. And as well as having metal hydroxides, we can also have compounds of ammonium, as in ammonium hydroxide or ammonium carbonate. So these would also be classed as being bases. We've already seen that some bases dissolve in water to form alkaline solutions. So what is a neutralization reaction? Well, in order for a neutralization reaction to take place, we're going to look at the reaction between an acid and a base. And when acids and bases react together, we get a salt formed and water. If we look at some examples of neutralization reactions. So if we've got an acid and a metal oxide reacting together, that would always form a salt and water. And the same is true as if you've got a metal hydroxide reacting with an acid. It will also produce a salt and water. If we've got an acid and a metal carbonate reacting together, we still get a salt and water being produced, but we also get carbon dioxide given off. So all of these are acids. All of these compounds here, these metal oxides, metal hydroxides, and metal carbonates, they're all bases. We're going to form these compounds called salts, and we'll look at how we name salts and what salts are in a second. And we always get water formed. And the only odd one out really is when you've got a metal carbonate, it produces carbon dioxide as well. So this is the general equation that you can apply to all neutralization reactions. An acid plus a base gives a salt and water. So if we look at an example of what goes on during neutralization reactions, if we take an acid such as hydrochloric acid, and we can imagine we could see some of the ions inside, we'll see that in the hydrochloric acid, we've got free hydrogen ions and free chloride ions dissolved and mixed and moving around through the water. Now, we haven't drawn the water molecules in here, it's just shaded as blue. So hydrogen ions are what make this acid an acidic solution. If we take a base such as sodium hydroxide, and we could see some of the ions in sodium hydroxide, we'd see we'd have some free ions of sodium, so free sodium ions floating through the water. We'd also have some of these hydroxide ions floating in amongst the water. And again, we haven't drawn the water molecules in this example here. That's just represented by the blue color. So this is our acid, hydrochloric acid. It's going to react with our base, sodium hydroxide. And we know from the general equation, we're going to form a salt and water. So let's have a look at what would happen. So if we look at what's happening first of all, remember that this is a neutralization reaction. So we're going to be removing these hydrogen ions. And what the hydrogen ions do is they combine with these hydroxide ions. So we've got a H and an OH, and they're going to combine together to form water. So this is similar to the dissociation of water reaction that we looked at before, where we could take a water molecule and break it down into hydrogen ions and hydroxide ions, and that's a reversible reaction. Well, this is just the hydrogen ions and hydroxide ions joining together again to form a water molecule. So these are additional water molecules, additional to the ones that we already had in the solutions. So it's a new product being formed. So this is actually written on the side here. So this is water molecules. Finally, we've got this salt. Now in this case, what we've got in the salt is we've got ions of sodium and we've got ions of chlorine. So sodium ions and chloride ions would actually still be dissolved in solution, but it would form the salt called sodium chloride. So this would be a solution of sodium chloride, okay, in a solution of water. So how do we name these salts? How do we know that this salt is called sodium chloride? Well, when you're naming salts, it depends on the acid and the base that you're using. That determines the name of the salt. But a salt name is divided up into two parts. The first part of the salt name comes from either the metal ion or the ammonium ion that you've got in the base. So remember, bases are either metal oxides, metal hydroxides, metal carbonates, or they could be ammonium hydroxide or ammonium carbonate. So the metal ion or ammonium ion gives you the first part of the name of the salt. The second part of the name of the salt depends on what acid that you've used. Now, if you look at the name of the acid, it will actually give you a clue as to what the name of the salt is going to be. So if you use hydrochloric acid, whatever the salt it makes is going to end in chloride. So you can see the hydrochlor bit there gives you a chloride salt. Nitric acid, again, if you look at this name nitric, it's going to make a salt called a nitrate. Sulfuric acid gives you a sulfate, and phosphoric acid gives you a phosphate salt. So if you look at an example like the one we looked at before, if you've got hydrochloric acid reacting with sodium hydroxide, you should recognize the sodium hydroxide is the base. So we're looking for the name of the metal ion or ammonium ion. Well, here's the metal ion here, sodium. So that's the first part of the name of the salt there. And then because we've used hydrochloric acid, the second part of the name of the salt is going to be chloride. So the salt in this case would be sodium chloride. And then don't forget you've got water produced as well. So typical example you might get in an exam question might be to write a word imbalanced formula equation for the reaction between sodium oxide powder and nitric acid. So we know from the question that we've got sodium oxide reacting with hydrochloric acid. And you should recognize that sodium oxide is a metal oxide and that hydrochloric acid is an acid. So out of the general equations we've looked at before, an acid plus a metal oxide is going to give you a salt and water. So acid plus base gives salt plus water. That's the general equation to remember. So the salt that's going to be formed in this case, because we've got our base here contains sodium ions, the first part of the salt name is going to be sodium. And then because we've used hydrochloric acid, the second part of the name of this salt is going to be chloride. So the salt will be sodium chloride. And then we've got water added as well. So that would be the word equation. To then write the balanced formula equation, the first thing you need to do is to work out the formula for sodium oxide. So this is where you're going to use your valency rules. So we've got sodium with a valency of 1, oxygen with a valency of 2. So when we swap those numbers over, we can't simplify them, we're going to write it down as Na2O. I'm going to put the state symbol S because in the question it told us we've got sodium oxide powder. So the S tells us that this is a solid state, in other words, a powder. For hydrochloric acid, the formula for hydrochloric acid is HCl, and we'll look at how we can calculate the formulas for acids a little bit later, but they are in your booklet of notes, so you can just look them up for the time being. But we can work it out in exactly the same sort of way using valency. So hydrogen has a valency of 1, chlorine has a valency of 1, so the formula is HCl. And all acids are in aqueous solution. So the AQ tells us that this is hydrogen ions and chloride ions are dispersed and separated and moving around through water, so it's an aqueous solution. So we need to now name the salt. Now the salt is sodium chloride, and sodium has a valency of 1, chlorine has a valency of 1. So again, we can work out the formula, but we've also got to think about what state symbol we can put for sodium chloride. Would it be in solution? Would it be a solid? So what we need to do now is to look in your data book and find the solubility tables. Now when you look at your solubility tables, We've got the various metals listed down the side here, and we've got the various compounds that can form. So we're interested in sodium chloride. So if we identify sodium chloride here, we can see that sodium chloride is very soluble in water. So we know that it's going to dissolve in water and it's going to form an aqueous solution. So now we can add the state symbol AQ to show us that sodium chloride is dissolved in solution. So remember, that tells us that the sodium ions and the chloride ions are dissolved, separated, and moving through the water. And then finally, water, we can just write down as H2O, and this is in its liquid state, so it's L for liquid. And the final thing we need to do is to balance the equation. So if we look, for example, at sodium, we've got 2 sodiums on the left. We've only got 1 sodium on the right. So we can start by putting a 2 in front of the NaCl. That gives us the 2 sodiums we need, but it also gives us 2 chlorines here. So on this left-hand side now, we need to put a big 2 in front of the HCl. That gives me the 2 chlorines, and it also gives me the 2 hydrogens to balance the H2 over here. And just to double check, we've got 1 oxygen and 1 oxygen, and that's now the balanced formula equation. Second example, write a word and balanced formula equation for the reaction between phosphoric acid and calcium carbonate lumps. So again, we know from the question that we've got phosphoric acid and we've got calcium carbonate. We should recognize that phosphoric acid is an acid and the calcium carbonate is a metal carbonate. It's a base and it's a metal carbonate base. And we know if we've got an acid plus a metal carbonate that we're going to get a salt and water and also carbon dioxide gas. So now we can finish the word equation. The name of the salt, well, first of all, we're going to look at the base and we're looking for the name of the metal ion or ammonium ion. Here we've got the metal ion is calcium, so the salt name is going to begin with calcium. And because we've used phosphoric acid, it's going to form calcium phosphate plus water plus carbon dioxide. So that's the word equation. So again, we need to work out the formula for phosphoric acid. So if we use valency, the hydrogen has a valency of 1. The phosphorus group ion you'll see on page 8 in your data book, that's PO4, and that has a valency of 3. So the formula is going to work out as H3PO4. And again, the aqueous tells us that these hydrogen ions and phosphate group ions are separated and dissolved and spread through the water. It's in an aqueous solution. For calcium carbonate, calcium has a valency of 2, and the carbonate group ion is also got a valency of 2. Remember, if you see ATE in a name, you should be looking on page 8 to look up the group ions. We can simplify the 2 and the 2 to 1 and 1, which gives you the formula CaCO3. And again, I know the state symbol to use is S because in the equation, and the question, it told us we've got carbonate lumps. So that suggests we've got solid. So for calcium phosphate, we need to work out the formula again. Calcium has a valency of 2, and the phosphate group ion has a valency of 3. So if you swap those numbers over, you can't simplify them, you should end up with a formula of Ca3PO42. And don't forget, because we've got multiple group ions here, we need to put the phosphate group ion in brackets, and then the 2 outside to show we've got 2 phosphate group ions. Water, before we go on to water, let's have a look at the solubility tables to decide on what state symbol to use. So again, we're going to be looking up calcium phosphate. And if we look up calcium phosphate here, it says it's insoluble. That means it's going to form a solid. And we'll look at precipitates later, but because it's insoluble, we know it's going to form a solid. So we're going to use the state symbol S. Okay, and we'll look at insoluble solids and precipitates a little bit later in the course. We can add H2O and L to show that this is in its liquid state, and carbon dioxide is CO2, and the state symbol G telling us it's a gas. And if we balance this equation, okay, we should end up with those numbers there, and that's the balanced equation. You can go through the balancing of the equation a little bit later, and if you struggle, just put a question onto the team chat, and we can talk you through that one. So that's just 2 examples of forming salts. So hopefully by this short video and going through the notes, you should now be able to tell me that a base is either a metal oxide, a metal hydroxide, or a metal carbonate, and can also include ammonium hydroxide and ammonium carbonate. You should know that a neutralization reaction is where a base neutralizes an acid, And the general equation for that is going to be acid plus base giving us salt and water. And if you include a metal carbonate in that reaction, you also get carbon dioxide produced as well. You should know that salts are made when bases and acids react together, and it's formed when the hydrogen ion that's in the acid is replaced by a metal ion or ammonium ion. And finally, when we name salts, the first part of the name of the salt comes from the base, and it's the metal ion or ammonium ion. And the second part of the salt name comes from the acid. And you should know the various acids and what endings they give to the salt name. Hope that helps.